This video is to replace the earlier video which doesn't have sound, and thank you for letting me know. I wasn't aware of it. For some reason I didn't check it yesterday. After recording I just right away uploaded it actually on YouTube, and looks like it didn't have the sound for some reason. I don't know why. I hope this will have it. So what I'll do is I repeat the same exercise here again, and this is the thing that we did in the classroom as well. So I'll just choose one of this as X and the other one will be Y here. This is the same file as we had, as we worked on before, right? So let's do this. It will run the regression, simple linear regression, but for that I need stat plus. So you should have installed it by now. So click on the stat plus. If you haven't, just go to the announcements page that I made, and there is a link there in the first announcement I think I made. And once you install it, you can find it in the applications, among the applications actually in your PC or in your Mac. I should say Mac, it's not for PC. So now next, once you are here with the data and with the stat plus here on the menu, you just click on statistics and go to regressions, linear regression, and in the dependent variable box you just enter the dependent variable that you would like to have as a dependent variable, a variable that you would like to have a dependent variable. So let's take this compensation as a dependent variable this time. It doesn't matter which one, whichever you choose, but the assumptions and procedures will be the same. So this is shift command down. So I highlighted my, oops, I shouldn't click that. I should click on this. So I highlighted my dependent variable, and then second is the independent variable. So it's shift command up, highlights all. Notice that I highlighted the string as well, the title. Usually if you highlight it, you have to check these labels in first row box here, and you go to advanced options and check these as well, and you will see why in a minute. So click OK now. Now once its output is ready, okay, it's ready here. Let's zoom a bit in, and what I'll do is I will not look at this part here. We discussed this in the class, and we've taken notes, and we know how to calculate F, we know how to calculate T-stats, and then obviously the confidence intervals are given here, so you can use them. But let's look at the residual analysis. For that we need the residuals, and they are here. They are given to us or produced to us already, and for us already, that we can use now. And these are standardized residuals, and basically these are Z values basically of these residuals. And you know how to create this from our normal distribution classes that we covered. So what we do is we'll use the original residual values, and let's see what we see. So the first of the graphs here, I think Windows version will have more graphs, but Mac version for some reason only produce 2 graphs. So we'll start with the first one, and we may not need the second one actually. The second one is this is predicted values, so we don't need that. So what we do here is let's have a look at the this is the independent variable returns. Let's have a look at whether the assumption of linearity in simple regression analysis is met here using our data. So what I would suggest you is to see if you can find the data, this data, to be within some sort of a constant band interval. For that you can use this. You can go to picture, shape, and have a line, and draw a line here and another line right here, and see if you have fairly randomly distributed residuals. It looks like we don't have this sort of thing, because most of them are clustered around this 0 point. So this is residuals. Let me see if I can. Okay, I can do that. Yeah, these are residuals, and so basically y's are residuals, and on the x-axis, oops, yeah, my just laptop is not okay, good, not behaving well now. So okay, 20, right? So it looks like we don't, our linearity assumption may have, linearity assumption using our data may have been violated in this regression. so residuals are not linear. Next thing we look at is we still use this this graph. Again, if the residuals were independent, we would still be seeing no cluster around here. We could be seeing all these dots class kind of randomly distributed across these points. However, they may be actually randomly distributed if we delete all these, because these seem to be very large values. It may not be necessarily an outlier or outliers, because we need to check whether they are 3 standard deviations away from the mean residuals. You can check this here. But I'll leave it to you to check, because I think we covered this in earlier lectures, and you can look at the notes if they are, but this is also not an important one for the homework at the moment. But what is important is your ideas about whether your opinion about whether your data that you're using will have a pattern, no pattern, sorry, in this plot, in this sort of plot, where if there is no pattern, you would expect these residuals to be randomly distributed all over the place rather than clustering, or they shouldn't show us some sort of cyclical pattern, something like that. So long as they are randomly distributed, these assumptions will be met. They will not be violated. So independence and linearity assumptions, I mean. You can check for normality of this, but it's also not a requirement. If it is a requirement, what you do is you create a histogram using the residuals and see if they are normally distributed, or a percentage polygon, or just a polygon of this distribution would also be a great tool to check for normality. Now, another thing that you can check here is whether the errors are the error variance is constant or not. I can see that over time, as x increases, we have more or less constant values around here, but we have some sort of increase here. So it's just this would have to go up, obviously. I should have done it before, but yeah. Well, more likely this looks like this actually. Yeah, this is the sort of thing I'm seeing here. Because of this one value, we have non-constant variance basically. Even then, even if you pull it down, we don't see this parallel lines. The lines are actually pointy. In here it is going into pointy, so it's like a fan-shaped kind of distribution, or fan shape of error pattern here, a plot, fan shaped plot of the errors here. So we would like to see some sort of, again, distribution or plot of these errors between some constant bands of upper and lower bound, but we don't see it here. So in this case, we may be violating the homoscedasticity assumption, which tells us that errors must have constant variance. So their variance must be constant, or some number, rather than changing over x values as x values change. So these are the two analyses you can use in your homework, or later on you can use these assumptions before you run your regression. Before you make decision to keep the regression results or not, because if you don't violate these assumptions, this coefficient estimator is biased and is not efficient as well at the same time. Now, next thing is to check whether there is autocorrelation in your residuals. So we have to plot our residuals against the time. So time in x-axis and y-axis will be residuals. I don't see it here, so we'll have to create it ourselves. Well, it's not that difficult, so you just have to create another scatter plot, but using these residuals against the time variable. So you go to chart, scatter. First scatter is sufficient for us, so right click and select data. Now start adding a new series here. I need x values to be empty, so leave it, but in the y values I will highlight these residuals without highlighting the actual name of this residual. So shift command down, right, so done. Then label here, can I write it? No, it doesn't give me, so let's label it as residuals. Done. Now click OK. Okay, so we have this residuals. Now in this plot I can see, well, the purpose is to see if there is a cyclical kind of movement here among the residuals over time. So we have over 200 observations here apparently, sorry, not observations, data points here. Now what we have here is these are residuals, and I assume I plotted it correctly. If it is correctly, and you'll have to check it in the video that I put the residuals on the y-axis. That's what I did, I believe. But anyway, not to waste time. In this plot, we would like to see some sort of a pattern that doesn't follow cycle, like the residuals follow. I mean, doesn't give us the cyclical movements or shape, and at the same time we do not want a kind of expanding, yeah, shape. So we would like to have them within some sort of a band, let's say the constant band as we had before, and we do not want them to again follow any let me see, any pattern. So let's put a band here. I'm just thinking, while I'm speaking, I'm just thinking about these that are actually distorting the picture much to a great extent here, because this is a very large value here compared to others, and as a result this will compress the smaller value, so it looks like very tightly kind of closely, neatly, tightly what do you call this, distributed pattern here, but it may not be actually. You might have to delete that one. However, we'll leave it for now, but this is enough for us. Basically what I see is over time I don't see this cyclical pattern, so residuals are not suffering from serial correlation. Serial correlation is when the current values are correlated with its past values, so this is not the case here. Right, I think that's it for now, and hopefully you will use this video to message in the video to analyze your data, and hopefully it will not be difficult. And as I said in the class, the things that I described in the book usually are very easy to understand, to see, and very neatly made up problems, and the data looks very nice. But when you have the actual data, and when you deal with actual data, it's very hard to make a decision. Again, here I'm just thinking about these three. I mean, usually if they are outliers, I would delete them and then run regression again, and then we'll look at it carefully, because these also cause a lot of trouble in a simple linear regression. But we don't need this for our homework at the moment. But yeah, in an actual scenario, I mean in an actual case where you are actually doing some work with the regression analysis, then make sure that you identify this, whether they are outliers or not, and then if they are, delete them, and then do the regression analysis after that, and then check for normality assumptions, especially this autocorrelation assumption. So as I can say, there is no problem in this dataset, but have a look at yours, and if you detect some sort of, if you think that there are outliers in yours, make sure that you comment on that as well. However, this wasn't a requirement, so it would be nice to have your thoughts about if there are outliers or not in your data. So that's it for now, and I hope you will find this video useful, and it will have a sound as well. I'll double check that. Yeah.